Power outages can happen unexpectedly and last for hours or even days, leaving us without access to essential electrical devices. One solution to this problem is to invest in a solar generator, which can provide a reliable source of power during outages. However, it's important to select the proper size of a solar generator to meet your energy needs. In this video, we'll discuss the steps involved in determining the size of a solar generator to have during power outages. A solar generator is essentially a large battery bank that can store electricity for later use. It can either be plugged into the wall or use solar panels to generate electricity and recharge the battery bank. It typically consists of portable solar panels, an inverter, a battery, and various electrical outlets for connecting devices. To charge a solar generator with the sun, simply place the solar panels in direct sunlight and connect them to the generator using charging cables. A solar panel will then begin to generate electricity, which is then stored in the battery for later use. And most solar generators can also be charged using an AC outlet or a car charger, providing additional flexibility in how they can be powered. The batteries will generally be lithium or lithium iron. The lithium iron phosphate, or LFP, lithium ferrous phosphate, makes the generator heavier, but it will last considerably longer as it can be recharged through many more cycles than the standard lithium batteries. During a power outage, a solar generator can provide a reliable source of electricity for essential devices such as lights, medical equipment, phone chargers, fans, computers, refrigerators, and appliances. Unlike traditional generators that run on gasoline or diesel fuel, solar generators don't produce any harmful emissions or require any ongoing maintenance. They are also relatively silent except for the cooling fan, and can be used indoors without any risk of carbon monoxide poisoning. In addition to providing backup power during outages, solar generators can also be used for camping, RVing, and other outdoor activities where access to electricity may be limited. They are also a great option for people who live off-grid or in remote locations where access to electricity is limited or non-existent. When evaluating solar generators, there are three main specifications we want to look at. The first is wattage. This will determine how much power can be used at one time. Think of a garden hose as an analogy. How much water can flow through the hose at once? The bigger the hose, the more water. The higher the wattage in this case, the more electricity that can be drawn from the battery at once. The second main specification that we want to take a look at is how big is the battery and how long will it last. We'll use the term watt hours to help us out here. To continue with our analogy, this is like the water storage tank. How much water can the tank hold, and how long will it last based on the flow of water through the hose? And the third specification that's very important to take a look at is how long does it take to recharge the generator? You want to look at the maximum charging input. So let's jump right in. To properly size a solar generator for your family, you'll need to do a little homework first. Now, I've made a simple spreadsheet to keep track of this, and I encourage you to do the same, or at least write it out on a piece of paper. Identify the devices that need to be powered during a power outage. Think of your critical electronics for healthcare, communication, lights, food preparation. Identifying these devices is the first step in determining the right size of a solar generator to invest in. We're going to make a list of all the devices you plan to use and their power ratings in watts. In this example, I've selected a few items that I definitely want to power during a power outage. A fan, especially during extreme heat, a phone for communication, light, portable refrigerator to keep medications and some food cool, and finally a hot plate that will be useful in both preparing food and boiling water. Now, to figure out the watts for each of these devices, first we look to see if there's a plate or a stamp on the device itself that gives the wattage. You can also look at the product manual, as well as online to determine this figure. If you see the device's amps and volts, that's almost just as good. You can multiply amps and volts together to get the watts. And finally, if you can't find the wattage anywhere, or the volts or the amps, you can look online at one of the many lists of average device wattage requirements. While this is not extremely accurate, it is better than nothing. So let's begin with this fan. As I mentioned before, it would be very important if the power goes out during a heat wave. In this case, we can see the voltage, which is the standard 120 volts, and the amperage is at 0.3. When we multiply these two numbers together, we get 36 watts. And that's the number we're going to enter here. The phone will charge up to 27 watts, which I had to find online on the Apple website. So we'll write 27 watts for the phone. Now the LED lantern will draw 3 watts. Again, I found this online on the manufacturer website. The portable refrigerator is rated at 45 watts from their promotional material, but I will show you shortly how it can actually draw more than that. So stay tuned. Now we can see on the bottom of the hot plate that it is listed at 1000 watts. Now this is a good time to suggest adding a few extra watts on top of the manufacturer's figures so you make sure that your solar generator can handle the load. Once you have a list of all the devices you plan to use during the power outage, along with their wattage, determine which devices you need to power simultaneously. Add up the power ratings of all these devices that you have to run at the same time. And for this example, let's say we're going to run the hot plate at the same time running the fan and the portable refrigerator. We add up the watts, we come up with 1081 watts for those 3 devices. So I'll want a solar generator that is rated for more than 1081 watts. Next, we estimate the duration of use of each of these devices. Now this step is an estimate of how long you plan to use the devices each day. This will help you determine the total energy in watt hours required per day. To determine the watt hours required, you simply multiply the watts times the hours you're going to use that device. We'll show some examples of this momentarily. Next, you'll want to calculate and add up all the watt-hour requirements for all the devices you'll need to use each day. This is the second value you'll need, so let's calculate watt-hours for our devices. Now I'm estimating the fan will run for 8 hours per day, especially if the power goes out during an extreme heat event. So if we take 8 hours times 36 watts, that equals 288 watt-hours. Now, I'll plug the phone in for charging for about 2 hours per day, so we'll multiply the 2 hours times the phone's 27 watt requirement. That comes to 54 watt-hours. The LED lantern will be on for an estimated 4 hours per day during a power outage. So we multiply 4 hours times 3 watts. That equals 12 watt-hours. The portable refrigerator freezer is listed at 45 watts, but as I mentioned earlier, it actually draws a little more than that when it's hot outside and it's needing to run more. It probably averages out with cooler weather, so we'll keep it at 45 watts and we'll estimate that it will actually run the compressor for 15 hours per day. So 45 watts times 15 hours is 675 watt-hours. We'll use the hot plate for only about 1/2 or 0.5 hours per day. So 1000 watts times 0.5 hours equals 500 watt-hours. And finally, I've gone ahead and added our Ninja blender that pulls 1500 watts, but we only use it for approximately 2 minutes per day. So the math looks like this. 2 minutes equals 0.033 hours. Times 1500 watts equals 50 watt-hours. If we add up all the watt-hours for the devices we plan on using each day, we come up with 1,579. So we'll need a solar generator that is rated at more than 1,579 watt-hours. Okay, let's take a moment to think about this. If the power is out for, let's say, 3 days, and you use up the entire battery of your solar generator in the first day, how fast can you get that generator recharged with the solar panels? and this assumes that it's not cloudy. This is the final value you want to compare as you're looking at different generators, and it's called the maximum charging wattage, which will determine how quickly the generator can be recharged, whether it's plugged into a wall or being charged by the solar panels. There are a lot of variables to consider here. When using the solar panels, is it sunny or is it cloudy? What is the wattage of the panels, and how many panels do you have? What is the maximum charge capacity of the generator? So let's take a look at this particular solar generator that has a maximum solar charge rate of 1,200 watts. The portable solar panels that are sold with this generator are 200 watts each, so a total of 6 panels could be hooked up at once. Now these panels are fairly expensive, so we'll talk about prices here shortly, but let's assume we have 4 200-watt solar panels attached. And the sun is at the perfect angle, and we're able to draw 800 watts from the panels to recharge the generator. If the battery was at 0 when you started, it should take 3 to 4 hours to bring it up to 100%. Let's take a look at 3 different solar generators, for example, to see if they meet our requirements. The first is the generator we've been demonstrating in this video, the Pecron 2000 LFP, which stands for, again, lithium ferrous phosphate, or it's the lithium iron that we're looking for, because it has a lot of charge cycles compared to a standard lithium battery. Now this one has 2,000 watts, 1,920 watt hours, and a maximum charging wattage of 1,200 watts. Now this particular generator alone without the solar panels costs approximately $1,169. Now with 2 panels, it's $1,769, and with 4 200-watt panels for a total of 800 watts for charging, it costs $2,369. Now for comparison, here's another popular brand called EcoFlow, and this is the model EcoFlow Delta, with a wattage of 1,800 watts, watt hours of 1,260 watts, with a max input of 400 watts. Well, we can see immediately when we look at watt hours that it does not meet our requirements. We need 1,579 watt hours, and this only provides 1,260 watt hours. Now let's look at another popular brand called Jackery. The Jackery 2000 Pro has 2,200 watts, 2,160 watt hours, with a max input of 1,400 watts. This popular generator definitely meets our power requirements, and it comes in at a price of around $1,400 for the generator itself, and add on 4 200-watt panels, and we're looking at around $3,999 total cost. In conclusion, solar generators can be a game changer when it comes to emergency preparedness. And in this video, we discussed how to determine the best size of generator for your family. To size the solar generator properly, first determine the wattage of all the devices you will power during an outage. Decide which devices you need to use at the same time. Add up their wattage and make sure your generator wattage is high enough to cover that. Determine how long you'll use each device each day that you have connected to that generator, and figure out the watt hours. Add up all the device watt hours to determine how long your generator will provide power before needing to be recharged. Compare the input wattage for each generator to determine how fast they can be recharged. As all device wattage specifications aren't exact, make sure you give yourself some wiggle room and buy a slightly larger generator than you think you'll need to ensure that it can handle the load. And finally, keep the generator plugged in and charged up so it's always ready to back you up when the power goes out. This wraps up another video about getting informed as it relates to your emergency preparedness. Check out our website to learn more about getting informed, making a plan, building a kit, and staying informed so that your family's prepared when a disaster happens.